Hello students, in today's lecture we will be solving the example number 6 which is based on the Kirchhoff's rule. So we'll start with understanding the requirement of the question. Determine the current in each branch of the network shown in the figure. We have to determine the current in each branch like branch AB, branch AC, branch AD, then BC, CD, and then BED, BEDE. So these are the branches in which we have to determine the current. I'll highlight the branches for you. Just see. Branch AB, branch AC, branch AD, then branch BC, branch CD, branch DE, branch BE. So these all are the branches. Now we will get to know what all current flowing through the branch. Through branch A, B, current flowing is I2. Current flowing is I2. Through branch AC, I1. Through AD, I1 minus I2. BC, it's I2 plus I3. CD, it is I2 plus I3 minus I1. BE, it is I3, and DE, again it is I3. There are two voltage sources. One is in the branch AC and other one is in the branch BE and DE. The voltage across AC is 10 volts and voltage across these two is 5 volt. See over here. And we have many resistors with their values 4, 2 and 4, again 6 also. So these are the values of the resistors we have seen over here in the picture. Okay. Now we will start with our questions. In this question I will explain you the loops which we will be considering to apply Kirchhoff's loop rule. Okay. Let me clear up some space for our better understanding and clarity in the vision in the diagram. These circuit diagrams are extremely important, and if we understand how to read the circuit diagrams, it will be very easy for us to solve. Okay. So see over here, I am taking the light green color for coloring the loop number 1. Okay, this is the loop number 1. This is the loop number 1. I am taking light blue color to color the loop number 3, sorry, loop number 2. This is our loop number 2. And I am taking yellow color for showing the loop number 3. This is the loop number 3. Okay. So these are the loops. Now the current flow will be in this direction for loop number 1. Similarly, for loop number 2, the current flow will be in this, it will again be clockwise, and over here also we will take the clockwise current only. Okay. This will be the current direction. In every loop, direction pre-decided is in clockwise, okay. So these are the loops, these are the directions we have understood. Now I'll clear up the diagram so that we can see the values in it for the current and for the resistance. Now again here there is application of Ohm's law. What is Ohm's law? Ohm's law is V equals to IR. Voltage across any given point is equals to the current and the resistance in that particular point. So the combination of this current and this resistance will give us the potential drop across AB. Okay, that is how we are applying the loop rule. The Kirchhoff's second law. Okay, so we have considered the loop number 1. This is the loop number 1 as explained already. So this is the equation coming. This is the 10 which comes from this voltage multiplied with our ADCA. Okay, we have taken this loop over here. I have taken this loop. So this is the 10 voltage simply written minus 4 into I1 minus I2. This is the 4 ohm resistance into I1 minus I2. Then 2 ohm resistance. Current flowing through 2 ohm is I2 plus I3 minus I1. Then we have the current I1 flowing through this 1 ohm resistor, which is equals to 0. Upon simplifying this equation, we got equation number 1. That is 7I1 minus 6I2 minus 2I3 equals to 10. Now we are considering loop ABCA. ABCA, this one, okay. In this loop, 1 ohm into I1 plus 10 from here, then I2 into 4 ohm, then 2 into I2 plus I3. That is the equation which I have written down over here. Upon simplifying this equation, I got a simplified equation which I named as 2. Now I am considering the loop number 3, and for that I am changing the color. This is the loop number 3. Okay, just a minute, I'll just clarify. I'll clean the diagram so that we understand it more better. So I am considering this loop. In this loop, the direction is clockwise. So from clockwise, the current is flowing out from the negative terminal of the battery. See, this is our battery. The lengthier one is positive terminal, the shorter one is the negative terminal. If current is flowing like this, then like always we will see this is our clockwise and current is flowing like this. Then current is coming out from the negative direction. Okay, we have to take it negative. But the flow of current as well as direction of our loop, pre-decided direction, are both in the same direction. So we will take the voltage drop positive. But if the current is flowing in opposite direction like this and pre-decided direction is this, then we will take the negative voltage. Okay, so we have taken this direction. This is the flow of current, but over here the flow is in the opposite direction. So here we will take -5 and then we will take this 2 into this, then 2 into this, and we will be getting our equation like this. Now we got 3 equations from 3 loops. we got 3 equations from 3 loops. We will use the equation to solve further to get current I1, I2 and I3. Okay. So, first of all, I will write the equation number 1, 2 and 3. For our convenience, we won't get confused. And then we will solve it. Okay. 7I1 plus 6I2 minus 2I3 equals to 0 equals to 10. This is equation number 1. Second equation is I1 plus 6I2 plus 2I3 equals to 10 again. Third equation is 2I1 minus 4I2. So these are the 3 equations and now we will solve it. First of all, what we will do is we will add these 2 equations. Okay. Adding equation 1 and 2. So the equation is 7I1 minus 6I2 minus 2I3 equals to 10. Down it is I1 plus 6I2 plus 2I3 equals to 10. Once we are adding it up, these two will get cancelled. We will get 8I1 equals to 20. From here we will solve it. We will get I1 equals to 20 upon 8, which will give us a value of I1 as 2.5 ampere. We will put it in a box so that on further solving, when we need the value of I1, we can use it. Okay, now second step. In this second step, I will divide the equation number 3 with 2. Dividing equation 3 by 2. Equation number 3 is 2I1 minus 4I2 minus 4I3 equals to minus 5. Then we have to divide it with 2. Okay. Once we are dividing it with 2, we will get I1 minus 2I2 minus 2I3, which will be equals to minus 5 upon 2. Okay. So we have got another equation. This will be our equation number 4. Equation 4. Okay. Now we will solve this equation number 4 further with respect to the equation number with equation number 1. Okay. With equation number 1 or 2. This is what we have to decide. So with equation number 2 we can solve because I1 over here and I1 over here are similar. Then this 2I3 and this 2I3 are similar. But there is a difference of sign. This is positive, this is negative. So these two will cancel out. So we will solve this equation number 4 with equation number 2. So once we are solving this, our next step will be to find the value of I2. Okay. Now let's solve our equation with respect to the 2 we will be getting it like 2i1 plus 4i2 equals to 10 minus 5 upon 2. We know the value of I1 is equals to 2.5, or we can write 2.5 as 5 upon 2. So it will be 5 upon 2 plus 4i2, which is equals to 20 minus 5 upon 2. Here this 2 and this 2 will cancel out. It will give us 10. Sorry, not exactly in this way. I forget 4 doesn't have a 2. Okay. So it will give us this 2 and this 2 will cancel out. 5 plus 4i1 equals to 15 upon 2. We will have 4i2 equals to 15 upon 2 minus 5, which will be giving us this value, which is 5 upon 2 4i1. Sorry, again I have made mistake. This is I2. So the value of I2 will be 5 upon 8 amperes. Okay. Now it's high time for us to find the value of I3. In the above given any equation, if we substitute value of I1 and I2, we will get the value of I3. I choose equation number 2 because that is the simplest. Equation number 2 is I1 plus 6I2 plus 2I3 equals to 10. For you people, I will give you assignment. Substitute the value of I1 and I2 in equation 1 and equation 3 and find I3. Okay, and see whether you are getting same value for I3 or not using different equations. This is the assignment. Okay, now we will solve it further. I1 is 5 upon 2 plus 6 into 5 upon 8 plus 2I3 equals to 10. Okay, it will give us 5 upon 2 plus 30 upon 8 plus 2I3 equals to 10. It will again give us 2I3 equals to 10 minus 5 upon 2 plus 15 upon 4. 4, 15. We can do this. Okay. 15 upon 4. We will take the LCM, which will be 4. Then it will be 40 minus 10 minus 15. This is also minus. Okay. Not plus. Because both the terms are going from this LHS to RHS. And now we will have 2I3 equals to 40 minus 10, that is 30. 30 minus 15, that is 15 upon 4. And here we will get I3 equals to 15 upon 8 amperes. Okay. So we got the value of I1, I2 and I3. See, I1 is 2.5 ampere, I2 is 5.8 ampere and I3 is 15.8 amperes. Now current in the various branches will be AB equals to I2, CA equals to I1, DEB equals to 15 upon 8, that is I3, whereas ID was summation of the two currents, and CD equals to OA, which is having current of, I have to check the diagram to find out the current, so kindly find this current and put it over here. BC will have a current of 5 upon 2 amperes. So these are the currents in the various branches of the given network. Hope you understood the question. That's all for today. Have a good day. Bye bye. We'll meet in the next lecture where I'll be solving the another good question for you people.